Thank you so much for having me here today. And I'm going to give you a little sense of what it looks like for me. And this is going to look so totally familiar. This is how I look when I'm about to go to my day job. Oh, maybe it will help if we take this, go like this. Okay, day job. Okay. So this is me. I'm getting ready with my snow shovel, and I'm going off to my regular work at Oakley University, which is in Michigan. And I teach the course Learning How to Learn with Terrence Sanowski. He's the Francis Crick Professor at the Salk Institute. And this is Terry going to work at his day job. So that's one of the great things about new online learning is not only do you have students who can come from a broad variety of backgrounds, but you can also have professors who come from, who wouldn't ordinarily team up to make a course. And this can create new opportunities, I think, that we've never had before. So one thing that happened, though, was a few years ago, I was invited to give a talk at Harvard. Now, here I was, this little professor in Midwest, invited to speak at Harvard. Now, maybe to you at Cornell, it's not that big a deal, but for me, I thought, Harvard, I'm being invited to Harvard, and I was so nervous. And I walked into the room, and I became even more nervous because the room was packed, standing room only. And I thought, why are there so many people here today? And it turns out that at least in part, there were so many people because that one little course, Learning How to Learn, had on the order of the same number of students as all of Harvard's massive open online courses and online courses put together, made for millions of dollars with hundreds of people. And my husband and I and Terry did it mostly in my basement for less than $5,000. So what this tells you is that, well, I had no background whatsoever in anything to do with videography or online learning or anything like that. So this tells you that anybody can do it, but that not everybody does it. And so I think that it's important to realize that the online world today is highly competitive. It's a mixture of academia with Silicon Valley and all combined with a little bit of Hollywood. And we often say, well, we're teaching. We don't have to be entertaining. But in today's new world, you have to have something that's got a little bit of interest because you're not just competing with the other person in the other section of that class. You're actually competing internationally with what you're presenting. And the fact is, well-made online materials, people love them. So, for example, this is, you might wonder, so how did you make this massive open online course, this MOOC, so inexpensively? Well, whenever I needed somebody to model some little aspect of the course, I'd go to our daughters and say, hey. And so this is our older daughter. And she, at that time, she was in medical school. And I needed someone to model blocking out sound if you're trying to learn something effectively. Turns out she has these big honking earphones on her lap and was willing to look a little bit nerdy modeling these earphones. Well, in medical school, she was in her third year at that time, and she went in, there's 74 other students in her class, and she was sitting there in the class, and her professor that day was a distinguished cardiologist in Southeast Michigan. And he's teaching away, all the students there. He suddenly stops the class, points right at her, says, oh, you're the girl in the MOOC. And here this very distinguished professor was actually taking online materials because he was getting a lot out of them. So one, I think a mistake that we often make is we think of our students, we're very used to the caged students that we have in front of us, and we think that's the learning environment, sort of 18 to 24-year-olds. But the reality is that the number or the population who is actually intently interested in learning is something like this group of 18 to 85-year-olds. It's much, much bigger than you ever think. So I think a mistake we make, not only with our in-person courses, but sort of naturally because it's grandfathered in with our online courses, is we think, well, we got to target these 18 to 24-year-olds, because that's what we've always done before. But the smart universities realize that it's the 18 to 85-year-olds that you're actually targeting, including an immense population of people out in the working world who want to keep learning, want to keep upgrading their skills and broadening what they know. So just to give you a little bit of a sense of the kinds of things you can do with online learning, so this is a group of, so I'm standing on the left there. These are intellectually disabled individuals with IQs of 70 and below. Previously, they've always been warehoused. So in other words, they'd go through school or what they could of school, and then they would move into an institution and fold napkins. But by taking this online course on learning how to learn and learning how their brain works, they began to think of themselves as learners. They learn new skills. Many of the things I'll talk about today, they can tell you, and believe it or not, these students are actually now attending college. So you can outreach through these new means to people you've never been able to reach before and make an impact. This Learning How to Learn is in the world's largest refugee camp in Somalia. There's it's in jails. You can create courses that are like this. If I can say one thing, it is that don't be disciplinary bound. I'm an engineer. I'm a professor of engineering. I'm not an educator. I wasn't educated in the field of education. And sometimes I think the most important thing you can do is bring a fresh perspective to a new field by virtue of whatever training you have originally had. And in fact, Thomas Kuhn, in his book, Structures of Scientific Revolution, talks about who makes impact in science. It's actually two groups of people. One are people who are really young and haven't yet been indoctrinated into a discipline. The other are people who have been trained originally in one field and then moved to another field to look at it with fresh eyes and to bring in new ideas. So I should tell you a little bit about myself, my background. I grew up moving all over the place. So by the time I hit 10th grade, I'd lived in 10 different places. Now, this is all well and good. I think it's a great thing for children to grow up moving around a lot. But there's one thing though, and that is when it comes to getting a math education. Math is very sequential. And if you move, chances are that you're either ahead or behind wherever you move to. Well, when I was moving from Lubbock, Texas to Chelmsford, Massachusetts, when I was about 7 years old, they were suddenly way far ahead of me in the multiplication tables. Well, I just realized at that time, I'm just not good at math. I don't have the math gene. And so I'm embarrassed to admit it, but I sort of flunked my way through elementary, middle, and high school math and science. And I just loathed it. And so it is kind of ironic, since I am a professor of engineering nowadays. And one of my students once asked me, how'd you do it? He found out about my sordid past as a math flunky. And I thought about it. How did I do it? if I look back, I love this picture because it's like the last cute picture of me. But I was this little girl who I liked animals, and I liked knitting, and I liked weaving, and none of this analytical kind of stuff. And so I wondered what I could ever do when I grew up. Now, I grew up in a family that was resolutely monolingual, and you can guess what language we spoke. So I thought, well, if I can't do any of this math stuff, maybe I could learn a different language. But I didn't know how to do it because I couldn't afford to go to college, and there weren't college loans available at that time. So I finally found out there was one way I could learn a language and get paid for it, and that was to join the Army. So I did. I was right out of high school. I joined the Army, and you can see I'm looking really nervous about to throw a grenade. And if you knew how clumsy I actually am, you would know why I look so nervous. But I did learn another language. I learned Russian, and I ended up out on Soviet trawlers up in the Bering Sea, and I have some tremendous drunk Russian stories. But I just loved adventures and seeing the world through new perspectives. And so I also ended up at the South Pole Station in Antarctica, and that's where I met my husband. So I ended up, I always say I had to go to the end of the earth to meet that man. He's right there. But I began to realize something, though. And that was, I was 26 years old. I was looking to get out of the service. And to my surprise, recruiters weren't knocking on my door saying, we just gotta have your Russian language skills, even though I'd worked so hard to follow my passion and acquire these skills. And I began to wonder, have I inadvertently boxed myself in what I'm capable of doing by only following my passion and not doing something broader? So I remembered when I was working with the West Point engineers when I was in the Army, and I'd look at their books, and I'd open them, and they'd have these equations in them, and I thought, gee, that looks like a foreign language. And then I began to think, now wait a minute, aren't I supposed to be open to learning, to new adventures, to learning new things? And I thought, yeah, I'm supposed to be that. Why don't I see if maybe I can change my brain? And so I went back to remedial high school algebra, and I began studying, and if you looked at my book from back then, you would see all these dimples in the page. Why are these dimples there? It's because I'd get so frustrated. I'd read this stuff and it's like, did they write this on purpose to make it so you couldn't understand? I'd take a fork and I'd stab the page in the book. But how many of our students have experienced this same sort of thing when they are trying to learn something new? So back then, when I decided that student asked me a question, how did you change your brain? And I thought, I like to write books. Why don't I write a book about how that change happened? And turned out I had a good background related to neuroscience and understanding cognitive psychology and so forth. So it's kind of an interdisciplinary look. But at that time, I began to, I thought, I put the book together. It's a manuscript. And has anybody ever heard of this platform called RateMyProfessors.com? So I went to Rate My Professors, and there's a way you can download the names of the top 200 to 300 teachers of large classes who have the highest ratings for all sorts of different disciplines, like engineering, physics, psychology, English. So I downloaded over a dozen disciplines, over 200 to 300 top teachers, instructors' names, and I got their emails, and I emailed them all. And I said, would you be interested in taking a look at my manuscript? Shocking percentages of them said yes. So then I had to email all these men, and I was getting all this, and I got this great information back. And if you go to that book, A Mind for Numbers, you'll see all these little quotes from people, because they would give critiques on the manuscript, and at the end, they would often give me a really interesting quote, or something that I could ask them if I could quote them about. But there was something additional that I found fascinating. Many of these top professors, they used one technique that they didn't like to tell other people that they used. Anybody have any idea what that technique was? Yeah, it's like, is she trying to trick us here? It was metaphor and analogy. Now, why would they not want to have this shared? It was because if other people knew, especially in the STEM disciplines, if they knew that they were using metaphor and analogy, they would lambast them. They would say, you're dumbing the material down, you're making it too easy on students. But we now know from neural reuse theory that if you've laid a pattern, a neural pattern in place on one item, like let's say you understand the flow of water, which is really quite difficult to understand. That's why babies are putting their hands in it and fascinated by water flow. If you understand that concept and use that as a metaphor for electron flow, you can onboard students much more quickly into the idea of electron flow. Now, does it break down eventually? Every metaphor breaks down eventually. If you'll read the book Models Behaving Badly by Emmanuel Derman, who's one of the world's greatest quants, one of the first quants, he even talks about equations are models. They're metaphors for things. So, I thought that was such a fascinating thing. It was like this shared secret handshake that these professors had, that they didn't like to talk about their powerful technique for teaching because they were given such a bad time about it. And indeed, in traveling over the country over the last years, I've met 3 of the top 20 professors on ratemyprofessors.com, and they would come up to me and say, you're so right. I use metaphor and analogy all the time, but I don't like to talk about it amongst other professors because they do give me a bad time. But at any rate, neural reuse theory says if you learn something using metaphor and then you apply it to this new idea, you can onboard students much more quickly. So that's the kind of thing that you indeed do want to use. And in my working on this book and working on the MOOC eventually, I reached out to top neuroscientists, top cognitive psychologists. I myself have worked in the field of education as well as conventional engineering research for decades. And so what I'm going to present and share with you here today are some of the best things I've discovered from great researchers about how we can learn effectively. Now, the brain, as we know, is enormously complicated. But fortunately, we can simplify its operation into 2 fundamentally different modes. Now, the first mode I'll call focus mode. And when I say a mode, I mean physically there are a set of connections going on in focus mode. It's task-positive networks. And so you are activating, hopefully if you're looking at me now, you're activating a certain task-positive network as you focus on what I'm saying. But there's a completely different set if you're an engineering professor. It's an orthogonal set of networks, and that is what I will term diffuse mode. And diffuse mode is completely different. It's what you're thinking when you're not really thinking about anything at all. So thoughts are indeed coming into your brain. It's like when you're standing in the shower or going for a walk or riding on the bus. Thoughts will drift in, but you're not focusing where they go or what's happening. It's kind of arising spontaneously. Now, how could I possibly give you a better sense of what the difference between these two modes are? What am I going to use? Metaphor, yay! So the metaphor I'm going to use is that of a pinball machine. And if you're at least of a certain age, you will remember how a pinball machine works. You just go over, you pull out on the plunger, and a ball goes boinking out on those rubber bumpers, and that's how you get the points. So what we're going to do is we're going to take that pinball machine, and we're going to put it right on the human brain. So you can see the brain here. There's the nose, the ears, and there's the brain itself. So are you ready for it? Okay, there we go. Pinball machine on the brain. Now, this is our analogy for the focused mode of thinking. And notice how close together those rubber bumpers are. They symbolize the fact that focused thinking is often compact about one particular area. And often, in fact, you have patterns laid in focused mode by virtue of the fact that you have practiced and learned something. So let's say you probably know how to do multiplication, at least if you've got a pen and paper in front of you. So if I asked you to multiply 22 times 47, say, your thoughts would move right along as you were working that problem. The thoughts would move along those patterns that you have already laid. But what if you know multiplication, but you've never learned division? So division, in some sense, is like a pattern that is going to be there, but you don't know where there is, how you're going to lay it there, how you're even going to get to it to put it there. In fact, it's very, very difficult to figure out how to learn something new. And what your brain will often do is it will, let's say you're trying to work your first division problems. You'll find your mind naturally drifting back to the patterns you're already familiar with, for example, with multiplication. And what you'll find is you can't really do it very well. You don't really understand what's going on in the textbook. You make mistakes, you're struggling. You take a fork out, you stab the page, and then eventually you may get so frustrated you close the book and you walk away and you do something different. Now, when you walk away and you're doing something different, so your attention, your focus has gone off it, and I mean really gone off it, so it's not like you're just walking away but you're still kind of mulling about it, but your attention gets off it. That opens up this very different mode, the diffuse mode, which is often, it's actually a catch-all term for the mini neural resting states, the most prominent of which is the default mode network. But this mode of thinking allows your brain its thoughts range much more widely and broadly. You can't do that careful focused thinking like you can in the focus mode, but you can at least struggle around and get to a new place, mentally speaking, where you can begin to understand what you are trying to grapple with intellectually. So learning, as it turns out, often involves a sort of back and forth between that focused and the diffuse modes. And the reason for that is because you can't be in both modes at the same time unless you're taking certain forms of mushrooms, and I'm not advocating that. But so what I think what I'd like you to do now is I'd like you to just take a little look here at how I conveyed some of these ideas on the MOOC. So I took out the sound, but notice how I'm half body and I'm explaining something about that. Now I can actually appear beside the metaphor and make it like it's full body, like I'm talking, like I'm walking around inside my metaphor. That makes it so real for students to see this kind of thing, to have it full size. And so these kinds of ideas, this is actually, new approaches to online learning can sometimes improve on what you can do face-to-face. Because think about it this way. You're learning, if you're sitting in a class, you've got the professor's this tiny thing down towards the front of the class. You've got so-and-so right beside you who are coughing, moving around, flirting, somebody going in and out the door. But if you're watching a video and then coming in to actively work problems in class, that flipped modality, you can create these wonderful videos, wonderful learning experiences for students, sometimes that really do improve on what we can do face-to-face in class. All the more so because every lecture you give on a MOOC can be the very best lecture you've ever given in your life. Because if it's not good, you can just throw it out. Sometimes I think MOOCs are like, well, MOOCs are like dating. You know, dating is, you get all duded up, you're on your best behavior. If you have a really bad cold, you don't go on the date. Classes are like marriage. What you see is what you get. There's a bad day, the jokes fall flat. So that is another reason that some online materials can be powerful ways to help students to connect, to better understand the material. I'd like to point to one thing that happened when we were just doing this exercise. Did you notice that beforehand, hopefully, you were focusing on what I was saying? When we stopped and you turned to the people beside you, momentarily, you were in the diffuse mode. You kind of went through a blink of default mode network. And what that allowed you to do was start looking at what I was talking about in a fresh way. So this points to one of the reasons why active learning in the classroom is such a powerful technique. I don't think we can, certainly not in my discipline of engineering, we can't do everything active. Sometimes you want to explain something or get people on the track because we're all not Isaac Newton, that we can invent the differential calculus by ourselves. But at the same time, having a little bit of time to reflect, discuss, and talk and work with, you can see now why that's effective. You're able to do some consolidation and look at things with fresh perspectives. But I would bet you that at least a few of you are sitting here thinking, you know, we got another one of these professors here who's really kind of theoretical and giving us tools that we cannot practically use in our classrooms, because who actually has time to go back and forth between focused and diffuse? We've got certain things we have to teach within a specific period of time, and more than that, we like to procrastinate. So procrastination actually is I think it's a tremendous issue in all of education. So when we are teaching our MOOC, Learning How to Learn, around the world, the number one issue I hear about from students is procrastination, that is their worst issue. And oftentimes I think we forget as educators, we've kind of figured out ways to sort of get us through so that we're not quite as bad with procrastination, at least in learning. That's why we're eventually successful as professors. And so we tend to, when we're trying to help students improve their learning, We'll focus on things like deliberate practice, they should do things day by day and so forth, but we forget to give them the tools they need to help overcome procrastination, that before anything else comes to the learning table, we should address procrastination. And fortunately, there's a simple tool that is incredibly powerful. Before I say that, though, I'd like to point out that when you even just think about something you don't like, it activates pain centers of your brain. So what does the brain do? The brain naturally enough says, I will stop this negative stimulation. I can do that by shifting my attention. So what happens with procrastination is something like this. You think about something you don't like, and you don't feel so good. So your brain naturally turns its attention to something else, and the result is that you feel happier almost instantly. Now you do this once, you do it twice, no big deal. But if you do it very often, it's a habit, it's procrastination, and it can have terrible long-term consequences on your life. You can even think that you can't do subject X, that you don't have those genes, when it has nothing to do with that at all. It's simply that you procrastinated habitually, and few people can learn at the very last minute. Sometimes I think the biggest challenge with really smart students of the kind who you get here at Cornell is they've been very successful to procrastinate. In high school, they're so smart, they can do everything at the last minute, and then they get here to college, and it's not necessarily so easy. But they haven't learned the tools mentally to overcome procrastination. So here's that tool. This is one of the most effective I've ever found. And people on the massive open online course love it. It's called the Pomodoro technique. And this was invented by an Italian, Francesco Cirillo, in the 1980s. And it's so simple. I should say that Pomodoro is Italian for tomato. And he had this wonderful little tomato-shaped timer. Every once in a while, if you go on eBay, you can find an original Francesco Cirillo Pomodoro timer that's really good. Otherwise, they're kind of knockoffs and they're not so good, and those are easy to find, very cheap. But actually, any timer will do. I use a timer that's just, I download a timer and have it on my laptop. People often use Pomodoro apps. One of the most popular is one named Forest. So if you're looking for Pomodoro apps, look up something called Forest. You will kill a tree if you procrastinate. So, but if you don't, you can allow trees to grow. So to do the Pomodoro technique, it's so simple. You turn off all distractions. So no little ringy-dingies on your cell phone, nothing popping up on your laptop, and then you just set that timer to 25 minutes, and then you focus as intently as you can for those 25 minutes. Now, if you're like me, this is what I'll do sometimes. I will focus. I mean, daggers come from my eyes with focus. I'm working so intently, and I'm so kind of pleased with myself because I know how focused I am. And I'll glance up at the Pomodoro timer, because I know I've really been working, and I've just done 2 minutes of it. And my mind screams, I cannot do 23 more minutes. And I just do the Zen thing. I just let that thought go right on by, and I return my focus to what I'm working on, because the reality is pretty much anybody can do 25 minutes of a Pomodoro. But there's one more part of the Pomodoro that is incredibly important. In fact, it's the most important part of the whole thing. And that is to reward yourself. Now, by reward, I don't mean, oh, you have a cookie or something like that. You can listen to your favorite song. You can get up and move around. You can play a little of a video game that you like. If you have trouble getting back on task, after you've done a Pomodoro and given yourself a reward, set a timer for how long you want that reward time to be. That's a very helpful technique that people have found. People with kids, they use this Pomodoro technique to help their kids practice focusing, and they find it immensely helpful because with this technique, when you teach it well, you are teaching them how to focus, and now you understand that relaxing and not thinking are also an important part of that learning process. During this reward process, they're going into diffuse mode and they're consolidating what they've just learned. So this is also a very, very powerful technique for children. If they're very young, you may want to start with a shorter time frame for kids, but you'll be surprised. I know fourth grade classes that use the Pomodoro technique, and they give the entire class a reward if the kids were good during their focus period. So the only other little thing I can say is when you are setting about to do a Pomodoro, do not focus on completing a task. Because as soon as you think, I'm going to finish all of this homework, you've just activated the pain centers of your brain. So the Pomodoro technique is actually an effective way to sneak past the pain centers because you're just telling yourself, I'm working for 25 minutes. I don't care what I'm working on, I'm just working on it. And so don't focus on the task. I mean, you're focusing on the task itself, but don't think about the task. Just get to doing it, and this is very powerful. Now, learning is a lot like baking a cake. So, I mean, baking a cake, how do you bake a really good cake? You have a lot of different ingredients in it, and you gotta make sure all those ingredients work together well. You gotta make sure you get the icing, the cake, the batter, the eggs at the right temperature. And learning also has lots of different ingredients in it. Good learning does. So one of the important ingredients in good learning is sleep. So I know what you're probably like, I knew that, right? But you probably didn't know why sleep was important. So I'll use a metaphor to quickly give you a sense. And my little metaphors are neurons. These circles are neurons. And what happens during the day is as the day goes by, metabolites will come out of your neurons, and it's kind of like toxins in your brain. That's why as the day goes by, it can be harder to focus on really difficult things because you've got all these metabolites there. So what happens, you might think, well, look, you've got cerebral fluid flowing by, so why doesn't it just wash those toxins away? But the neurons are large. They're almost like boulders. And so what that means is the cerebral fluids can't flow past very easily. But when you go to sleep, something very interesting happens. Your brain cells shrink. So I love this part. I got to do this again. So here we go. So when you go to sleep, your brain cells shrink, and that allows those toxins to be washed away. So sleep is important not in part because it helps clean your brain, but there's also another reason, and I can show it to you here with these fantastic light microscopy images of a living neuron. This is a neuron before learning and before sleep. And with light microscopy, we can now see that same neuron after learning and after sleep. So it's the same neuron. And if you look, there, for example, right here, see that little spike coming out? That spike isn't there. It's the same neuron, spike is missing. What happens is when you learn something during the day and you go to sleep at night, that's when those little dendritic spines begin to pop out. That's when the real learning is taking place, when you're sleeping. So this is why it is so important to space out your learning, to do a little bit every day. Because what happens is you can only learn so much. And you learn, you go to sleep at night, only so many neural connections, new dendritic spines can emerge. And so, so that's why when you practice day by day, you're building and strengthening and allowing for new dendritic spines to emerge, and it creates a good neural architecture for learning. If you cram, so everything is like at the last, you spend 10 hours in one day, as opposed to 10 separate hours in 10 days, you will learn far, far less. You'll have a neural architecture that's weak, and that makes it much easier for your sort of little metabolic vampires to suck those weak patterns away, which is why sometimes students will do very well at the beginning of the course when the material is easy, and they're successful. They can procrastinate, and they're doing a great job. And then in the middle of the semester, they begin to struggle because they haven't been creating that good neural architecture, and then by the end of the course, they can really be struggling. So again, this is why dealing with procrastination and setting your classes up to minimize students' abilities to procrastinate can be a very, very effective way of helping your students to be successful in whatever you're teaching. I like to think of it metaphorically as learning is like building a brick wall. If you lay a layer of bricks, lay the mortar, let the mortar dry, and then, so you're laying the bricks, but you're letting the mortar dry in between. That takes time, but you get a good foundation. But if you don't do that, your structure looks a little bit like this. It's this jumbled mess that's not a good foundation for anything. So again, thinking of learning as kind of like it's got lots of different ingredients. Another very important ingredient in good learning is exercise. So we tend to, sometimes students will come to me and say, I just can't keep my focus on whatever I'm studying. I just don't know what my problem is. And I'll ask them, what's your exercise program? And they often don't have one. The exercise helps your ability to focus. And remember that at night when the little dendritic spines are emerging, well, exercise produces something called brain-derived neurotrophic factor, BDNF, and that is like a fertilizer for the brain. It actually helps those little dendritic spines emerge. So when you exercise, it is a powerful fuel for learning. It's one of the most powerful sort of tangential things that we can do to help affect and improve our memory and our learning abilities. So this mouse, this was the first study in the Proceedings of the National Academy of Sciences that it was done decades ago, and it showed how if you were trying to teach a mouse to differentiate between two different patterns, if you allowed the mouse to exercise and then you looked within the mouse's brains, these blue blobs are old neurons. The red streaks are new neurons. Mice that exercised not only learned more quickly, but had many more new neurons. So neurogenesis is related to learning, to improving your ability to learn, and exercise is a great, great way to help make that happen. But you might be wondering, there's thousands of studies that have occurred since then that all build on this and give us some of the exact metabolic pathways that are occurring, that are potentiated as we exercise. So why am I bringing up this somewhat older journal paper? And I couldn't help it because if you look, you can't really probably see from where you're sitting, but one of the co-authors was this fellow named Terry Sinowski, my co-instructor in the MOOC, Learning How to Learn. So we go out, my husband and I would go out to San Diego, and we're filming a little bit of the MOOC. And I asked Terry, I'm like, Terry, do you exercise? Terry's like, because he's just raving about exercise. And Terry's, exercise? Do I exercise? Next thing you know, here he is, he's almost 70, tearing down those mountains like a mountain goat, And off he goes down the beach. I love how this ends up here. Yay! But Terry he's one of the world's leading neuroscientists. He's simultaneously a member of all 3 national academies. He's an amazing human being, and I think part of the reason for this is he walks the walk. He doesn't just do this research. He takes the best ideas from research, incorporates them in his everyday life, and we can do that too. Now, I should touch on memory. So for our purposes, don't worry, we're not going to be super complicated. We can think of memory as kind of 2 different main flavors. One of them is working memory, that's like short-term memory. It's what we're holding in mind temporarily. And the other is long-term memory. Short-term memory, or working memory, we used to think that there were 7 slots, so to speak, in your working memory. You could hold 7 items. More recent research indicates it's maybe something more like 4 items in your prefrontal, or 4 slots in your prefrontal cortex, metaphorically speaking. In other words, you can hold 4 pieces of information in your mind at once. For example, if I gave you a phone number or something of that nature, we often cluster information together, so it still reduces it to something that we can hold in mind. And if I haven't had my coffee yet, I might be able to have 2 slots in working memory. But anyway, you can think of when you're focusing, it's almost like you have this octopus of attention that can reach down through those slots of working memory into your long-term memory and make connections there. So that's why learning often consists not only of holding things in short-term memory, but you've got to have something in long-term memory to connect into. So how do you get something from working memory into long-term memory? Well, kind of your mother was right when she said things like, practice makes permanent. What we found is if you practice with something, you will create a neural pattern. So if you're practicing a guitar chord, for example, you're creating a connection between neurons. And the more you practice that guitar chord, the deeper and richer that pattern becomes. So it's a little like this. You get a pattern because you've practiced something, then the more you practice with it, the deeper and richer that pattern becomes. So this brings me to the most important part of this entire presentation, and that is the idea of chunking. So when we're trying to figure something out, we've got this raw information, we're really trying to figure it, it's almost like our working memory is struggling to put this information together, to piece it together so it makes sense in our mind. And you can see, if you're imaging, your working memory is going a little crazy. But once you have figured that pattern out, so it's kind of, you see it, you understand it, you practiced it, you've got it, it's kind of like this ribbon, this chunk that you've got, that you have developed. And so when you really get something, you have this pattern, it's actually in your long-term memory, and when you want, your working memory, let's say you have nothing in mind, and then suddenly you want to try and remember the date that that Columbus sailed the ocean blue or something like that. You bring that up from long-term memory into working memory because you have that pattern there, and notice that the other slots of working memory are left free. So what that means is that you can create these connections. So let's say that you have a student, you're giving that student a big test. Often what you're trying to do is get them to connect ideas. If they don't have those ideas chunked in ribbons, what they're doing during a test, you give them the test, they're in this mode if they haven't studied, if they have studied, they're in this mode, and then they can draw up that other pattern and make those connections that you want to have. Sometimes I think that a big challenge for us is we are so empathetic and so caring in the academic profession that when a student comes to us and says, I really knew this material, I have test anxiety, our tendency is to actually believe them. But in many, not all, but in many, many cases, the problem is not test anxiety. The problem is when you sit that student down for the first time and they're looking at the material, if they have not studied well, they're in this mode. They're trying to figure things out, and they interpret that as, I have test anxiety, instead of, I haven't studied well. I don't know, because we never teach them what it takes to actually study well. I had a student come up to me once and say, how could I possibly have flunked this test? And he flunks a test in front of me, and I redlined all over it. He did a terrible job. And he said, how could I have flunked this test? I understood it when you said it in class. We have gotten so insane about the idea that if your students just understand what you say, that's the golden key, and they've got it. And we don't emphasize practice, repetition, and really kind of remembering, learning things, getting them in mind. And even when I say, dare I say the word memorize? Poets will often say, memorize the poem and you will understand it more deeply. And there's a lot to that. But when we take away things like memorization of equations, we're actually crippling students to remember key ideas. We don't want them to memorize everything, and we certainly don't want a bunch of rote learning. But at the same time, a few key things in memory, that is what learning is. You have to have some architecture that's created there, and sometimes some memorization of key ideas can help you get there. So this brings me to our younger daughter. So as I was asking my daughters, for help, I said, I need a model of someone who can back up a car really badly. I need somebody to mimic that. And my younger daughter's like, Mom, I can do that. I got that. So here you see, this is our daughter, our younger daughter, backing up the car. Now what I want you to see, it wasn't long before that she learned how to drive. So she is modeling what she felt like when she was learning how to back up the car. Notice her little face is so quizzical. It's like, oh, do I look in the front mirror, the back mirror, the side mirror, do I look behind me, and then off she goes in the ditch. But the thing is, when you're learning to back up a car and you first think about it, what's happening is you are in this mode. Which mirror do you look at? Or do you look in the front or the back? It's all overwhelming, and your mind it's trying to make a pattern out of it. But once you have made that pattern, you can just think, I want to back up the car, draw it into mind, and then with the other parts of your working memory, you can listen to that audiobook or talk to friends or see if your seatbelt is buckled. All sorts of, it's something that was previously seemingly impossible becomes very, very possible. So good learning often involves creating this sort of library of chunks. In fact, Anders Ericsson, the world's leading expert on the development of expertise, has said the discriminating factor of experts is that they have a tremendously large library of these well-practiced neural representations, mental representations, patterns in your mind. And so the more you can develop this library of chunks, the better you will be able to become an expert in whatever you're learning. Now, one of the biggest challenges I think that we have is that we often think that some of our best traits are really bad. And I'll give you an example of this. So, for example, poor memory. Most people think poor memory, you don't want to have a poor memory. It's a bad thing. But I am here to tell you that having a poor memory is actually a very good thing. And how could that be? So remember those 4 slots of working memory? Some people they actually have 8 slots of working memory or more. They can hold all this material in mind, and it's really retentive. Once they get it in, it just sticks. But other people are more like, okay, I've got those 4 items in working memory. I got them there. Ooh, shiny. And then they get distracted and something falls out. And they come back to it, and then they have to try to get it back into working memory again. But we've found something very interesting. In those people who have working memory that's not a good working memory, what happens is when something falls out of working memory, something else comes in. And people with a poor working memory are often, as it turns out, very creative. So if you have a poor working memory, you do have to often work harder to keep up with the intellectual Joneses, but the benefit is that you are often quite creative. And you probably, if you were given a trade-off of better working memory or you're more creative, you probably would not want to change what you are. So there's another thing, though, that we often think of as a bad characteristic, and that relates to slow thinking. So, I mean, who among us wouldn't like to be a faster thinker? I know that in my classes sometimes I'll ask some complex derivation and ask a question, and I'm not really even expecting an answer, and there'll be some person in the front row, by golly, they're way ahead of me. They could get up and teach the course. They're practically so fast in how they're thinking about these things. So what's there for the rest of us who aren't so fast? And what's there for our students who aren't so fast? Well, there's a lot there for our students. Think about it this way. You can, in a particular subject, and sometimes particular people, there's some people who have race car brains. They can get to the finish line really, really fast. And there are other people who are more like hikers in how their brain works. But a race car driver, think about what they experience. Everything goes by in a blur. A hiker can reach out, touch the leaves on the trees, they can smell the pine in the air, see the little rabbit trails, hear the birds. Completely different experiences, and in some ways, much richer and deeper. So if you are a slower thinker, or your students, they can still have things to add that even the geniuses miss. My hero in science is a man named Santiago Ramon y Cajal, and he won the Nobel Prize for his work in neuroscience. He's considered the father of modern neuroscience. And he said, I was no genius. And he wasn't just being, oh, sure, no, I wasn't a genius. He really wasn't a genius. There were others who were he would fumble his words, he didn't have a good working memory. It was really hard for him to do what he was doing. But he said, I had 2 traits that would help me be successful. One, I was persistent. But the second was that I was flexible when I was wrong. He said, the geniuses I have worked with, they're so smart that they're often used to being right, and they don't get used to correcting errors. And so when they make mistakes, they use their intelligence to come up with a way that actually, in reality, they're correct. And they inflexibly, they're unable to change their minds when they do make mistakes. So again, if you are sort of a slower thinker, there are times when you can see things, you're not jumping to conclusions, and you can change your mind more easily when you do make a mistake, so you can see things, again, that even the geniuses can miss. Now, as I'm wrapping up, I just want to touch on illusions of competence in learning. And so One of the most important little tools, if I give you two little quick tools to help in learning, the first is what I call recall. And this is, we often tell students, if you want to understand a really, really difficult, some kind of description that you're reading in a scientific journal, for example, we will tend to underline or highlight, we will reread it, and sometimes we'll even teach students make a concept map. But it turns out that all three of those techniques are nowhere near as effective as simply recalling. And recall simply means you look at the page, you try as hard as you can to understand it, maybe make a note or so in the margin, then you look away and see what you can recall as the key point on that page. That isn't just making you memorize. It is helping you to synthesize that key idea, and that, as it turns out, helps build your understanding better than any of these other techniques. And the other way to avoid our fooling ourselves about how much we've learned or how well we've learned is testing. Testing is probably one of the best possible ways to help students learn effectively. So we don't like testing because sometimes we have to grade tests, which is where artificial intelligence will eventually be a wonderful thing because it will help minimize our having to grade, kind of reduce some of the time we have to spend on this. But 1 hour of testing as opposed to 1 hour of just studying, students will learn far more in testing. So never neglect the importance. I test my students every single week. So they love it when I go out of town. They say, oh, Dr. Oakley can't test us this week. But I do want to make one little side comment about how students can, or how can adults keep learning and changing and growing even well into maturity. And there is an answer to this, and that is video games. No, really, there's some fantastic work published in Nature, for example, about Adam Ghazali's work, Daphne Bavelier. They've done some fantastic work that shows that action-style video games, they help build midline frontal theta, long-range theta coherence. These are the kinds of things that are basically behind why you can focus well. And so all of these, so when you have a good action-style video game, there's good evidence that it helps increase and improve your ability to focus. You won't find things like it increases your working memory. We don't have any way to increase working memory at present. But it will do things to help build your focusing ability. And so there are video games currently under review by the FDA, and they will become the first sort of drug, a video game drug to help you improve your attentional abilities as you age. So I'll just give you one little idea. This is from Brain HQ. So it's so wonderful that I go to their website. This is, I think, about the only one that I know for sure is, well, there's another math website, Smartick, that's a very good one. But this is Mike Merzenich has done this program, and he's a very, very outstanding neuroscientist. But the way they build your attentional abilities are things like this. Now, what's going to happen is 3 dots are going to appear on the screen. Whatever else happens, you need to follow only those 3 dots. See if you can do it. Now, imagine, if you get this and you're doing pretty well, they'll do 4 dots. And they'll do 5 dots. But you'll be amazed if some of these sort of game-like activities really do help you to, and evidence has shown that they work pretty well. So in closing, I would just like to allude to the idea of passion. We we tell students, follow your passion. And that's what I was told growing up. And I think it's an admirable thing. We all do need to follow our passions. But passions are a double-edged sword. Passions develop about what we're good at. And some things take much longer to get good at. So I always say, don't just follow your passions. That's what comes easy for you. Broaden your passions, and your lives will be greatly enriched. Thank you so much.